Well, hello. Welcome to the Isaac Flores Softwares Thankful Surface Protection Program, an engineering tool to better manage risk. If you are a fire protection engineer, consultant, member of the fire department, or a property owner that needs to evaluate adequacy of fire protection in a fuel terminal, then you need this program. Program scope. Let's read this. This is important. This program calculates the minimum water and foam supply needed to extinguish the largest single tank full surface type fire using manual means. The program assumes that the fire is quickly detected and has not spread to adjacent tanks. The quantity of foam and water supply needed to control a fire involving multiple tanks in a common dike is also calculated and presented to determine adequacy of protection involving multiple tanks. The level of protection based on the largest tank often falls short when a fire involves more than one tank. For effective fire control, protection should be based on the number of tanks located in a common dike. Let's begin. We're going to enter data for a few tanks. We click Data Entry button, and this Windows open. You go into Site Information and available fire protection. And then the program compares available fire protection to needed level of fire protection. We're going to enter our company name is ABC Company. We press the tab key and it takes us to the next cell. The address is 25 River Road in Houston, Texas. Contact is Joe Smith. Telephone number. And to this date, June 20th, 2013. Now we entered available fire protection. We have 5,000 GPM from a fire pump. Water supply quantity in gallons, we have 500,000 gallons. And we could say that's from a tank or reservoir, whatever you have. 1% foam concentrate, we have 3,000 gallons. And we could say the name of the foam, Ansel aaaffr. 3% foam supply, we also have 3,000 gallons. And that could be another brand, National Foam. aaaffr. We're done entering available fire protection. We click next. And our windows open up showing our common fuel terminal products: crude oil, ethanol, gasoline, kerosene, JP4, 5, 6, number 2, 4, 5, and 6 fuel oil. Now, there may be some products not listed here that may be stored in tanks, and we could get the product information by clicking Cameo. This opens a government database showing chemicals, and we could get the physical properties and flashpoint, and then click whether the product flashpoint is under or 100 or over, under 100 degrees or over 100 degrees, and then we type the products here. So let's begin. We have several tanks to enter. This, as we enter tanks, our foam is populated, and we're going to enter up to 1,000 tanks or more. We're not going to enter 1,000 tanks. We're going to enter about 4 or 5 tanks. So our first tank is tank 100, and we enter the tank diameter, 180 feet diameter tank. And this tank contains gasoline, so we look for gasoline. We click it, and there we go, and then we click next. When we do that, this window's open up so we could select the density based on tank diameter. Our tank diameter is 180 feet, and it says here to select the density of 0.16 GPM per square feet for tanks up to 140 feet diameter. Select the density of 0.18 GPM per square feet for tanks between 140 and 200 feet diameter, and to select a density of 0.20, 0.22, 0.25 for tanks larger than 200 feet diameter. We need to select a density of 0.18, so we click 0.18, and a window's open and we said tank data table has been populated. What do you want to do next? Enter data for next tank or N. We're going to enter another tank, so we click enter another tank button, and we label a tank number, tank 101. We enter 100, the diameter for our next tank, 160 feet, and that contains number 2 fuel oil. So we click number 2 fuel oil and click next, and the density is 0.18, so we select 0.18. We enter our next tank, it's tank 102, it's 120 feet, and that contains ethanol, so we click ethanol. We click next, and the density is 0.16, we select 0.16, and we enter another tank. Another tank is tank 103. Tank diameter, it's 150 feet, and it contains kerosene. Select kerosene, click next, select the density is 0.18, we select 0.18, and we're done. We have to enter, we're going to enter a tank that contains benzene. Benzene is not listed here, so we're going to enter this point. We're going to click Cameo, so we click Cameo and open the Cameo database. Cameo database opens, and it shows chemical products listed in alphabetical order from A to C. Benzene is listed on the data sheet B, so we click B. Open it up, and it opens up. Now we scroll down and find benzene. Here is benzene, we click it. It opens up finally. It's a flammable liquid. Here's the benzene data, chemical data sheet. It's a flammable liquid. It has a NFPA flammability number of 3. We scroll down and look for physical properties. Here's physical properties, and it shows the chemical formula, the flash point, low explosive limit, upward explosive limit, and other physical properties. We are merely concerned with the flash point. His flash point, the flash point is 12 degrees Fahrenheit. So we remember that and go back to the program. We click data entry form. No need to refill this form. The data is on memory. It's blank now, but the data is on memory. So we're going to click next. And now enter a tank number for benzene. Our tank number is 95. Our tank diameter is 120. And now we go to tank product name and enter the product name, benzene. And we select the flash point. The flash point of benzene is 12 degrees, so it's under 100 degrees Fahrenheit. So we click this button under 100 degrees Fahrenheit, and we click next. Now we select the density. It's 0.16, as the tank is under 140 feet diameter. Select the density, and we end. Windows go away. Now we go to the tank table. We click the tank table button. It takes you to the tank table. And here's a tank table, a table for tank full surface protection for 1 and 3% foam solution with 55 and 65-minute application rates. The information we entered was transferred to the tank table: company name, address, city and state, contact information, telephone, data survey, and it shows the information we entered: available fire protection, 5,000 gallons per minute from a fire pump, 500,000 gallons from a tank, 1% foam supply, we got 3,000 gallons, Ansel AFFF, 3% foam supply, we have 3,000 gallons national foam, And the information we enter the tanks shown here, they're listed in alphabetical order, numerical order, starting with smallest tank first. Here's the tank diameter. Here's the headings. Tank diameter, liquid product, benzene, gasoline, ethanol, kerosene. Liquid flash point doesn't show the actual flash point. It just says under or over 100 degrees Fahrenheit. Here's the densities. Here's the minimum water supply needed in gallons per minute. Here's the capacity in gallons needed per tank for liquids having a flash point under 100 degrees and for liquids having a flash point over 100 degrees over here. Here's the minimum foam supply needed for 1% for liquids having a flash point under 100 degrees and liquid have a flash point over 100 degrees here and there. And here's the minimum foam supply needed, 3%. Liquids having a flash point under 100 degrees and over 100 degrees here and there. This row keeps track of the largest demand, and this row keeps track of all the tanks demand. We have formulas that I used to develop the program. If you want to show the formulas, you click this button, show formulas, which are shown. If you want to hide them, you could hide them. Let's export this test data into a loss prevention report. So we click, you click any cell beneath the data and start scrolling up. As we scroll up, the data will cite itself. So now we basically highlighted all the data that we need to export, and we click Export Table. We go open a loss prevention report, and then paste the data as a picture. Click Paste Special, click Picture, click OK, and here's the test data pasted into a loss prevention report. We could also export data into a Microsoft Paint. Here we had it previously exported. We are going to select a new sheet, don't save, and just click Paste. So now we could save the data as a bitmap, PNG, JPEG, GIF type format, and copy the data into an Access database or a PDF database report format. Many companies are using Access database instead of Word, or some companies are using a PDF type report format. So we could attach the data as a picture to those type of reports. Let's go back to our report and see some graphs. See, determine adequacy protection. Let the graph tell us the level of protection. We click graphs and this window open and shows source supply versus demand graph for the largest single tank fire or fire involving multiple tanks. Many facilities are protected based upon the largest tank, and if the fire develops and spread to adjacent tanks, the level of protection may not be adequate to protect this type of fire scenario. So let's see. We're going to look at largest single tank fire. We click it. It shows water flow rate available versus needed. A water flow rate available, we have 5,000 gallons per minute. And for the largest tank fire, we only need 4,578. So the water flow rate is adequate. Let's click next and look at water supply capacity. We have 500,000 gallons. We need 235,000. So our water supply is adequate for the largest tank. Let's look at 1% foam supply. We have 3,000 gallons and we need 2,351. So our 1% foam supply is adequate. We look at 3% foam supply. We have 3,000. We need 7,000 gallons. So we need to double the 3% foam supply. And we could use the graphs to help us generate recommendations. Let's click next and see what happens if the fire spread to adjacent tanks. We need 5,000 gallons per minute for water supply. No, we have 5,000 gallons and we need almost 50,000 gallons. So if I spread to adjacent tanks, the water supply rate is not adequate. So we could make a recommendations on the amount of flow rate needed. Our water supply capacity, we have 500,000 gallons and it's adequate. We need 441,000. So capacity is adequate. A 3% fund supply, a 1% fund supply, we got 3,000 gallons, so we need 4,418 gallons. So that's not adequate. And our 3% fund supply, we have 3,000 and we need 13,253. So we definitely need to boost the fund supply, 3% fund supply. And again, we can use the graphs to make recommendation on the quantity of fund needed. We click next and we go back. We're done with our program. We could click go back to table. And now if we need to evaluate another terminal, we click erase data. This window's open up. It says erase tank data. Are you sure? If you're not sure, you click no, nothing happens. If you are sure, you click yes. All data is gone, but the table remains. Only the data is gone. Now you could go back, click data entry, and start entering data for your next terminal. That's it. This concludes our demonstration of the Isaac Flores Software's Thankful Surface Protection Program. Thank you for viewing it.